question says, let x be a 4-digit positive integer such that the unit digit of x is prime. It's a 4-digit positive integer and the unit digit is prime. And the product of all the digits of x is also prime. The product a into b into c into d, it's also prime. How many such integers are possible? So there's a 4-digit number and the unit digit is prime. If this number is prime and the product is also prime, how it can happen? It can happen when the other 3 digits are 1. Only then the product can be prime, because if you multiply any prime with any other digit, this number cannot be prime. So this is only possible when the other 3 digits are 1 and this digit is prime. And this digit has to be a single digit prime. So single digit prime are 2, 3, 5 and 7. So how many such numbers are possible? Only 4 numbers are possible, because these 3 digits cannot be anything else except 1. So these are the only 4 numbers. Okay, so that was an easy question, should be done within 30 seconds. This digit is prime and the product is also prime, only possible when the other 3 digits are 1. Okay, option 1 is the answer. Come to the next one. Now it says A, B, C, D, E are integers such that A can be equal to 1 or greater than 1, B is greater than 1, C is greater than B, B is greater than A, C is greater than B, and so on. A, B, C, D, E are geometric progression and LCM is the least common multiple of M and N. Then the maximum value 1 upon LCM, 1 upon LCM, 1 upon LCM, so on. Now we know if you want to maximize it, when it will be maximized? It will be maximized when the denominator is as minimum as possible. So we need to take the small values of A and B. Only then the fraction will be maximum. Now it is geometric progression and they are integers. So obviously I can take the common ratio as 2, 3, 4, so on. But if I take to make it, if I want to make it minimum, obviously I'll take the common ratio, which is R, as minimum as possible, which is 2. And I can start the smallest number as 1. So what can be the smallest 5 numbers? The smallest 5 number which are in GP can be 1 into 2 into 2 into 2 and into 2. This is the smallest 5 number which can be in GP. Right? So what is the LCM of 1 and 2? 1 and 2 ka LCM? It's 2. What is the LCM of 2 and 4? The LCM of 2 and 4 is 4. And similarly, the LCM of 4 and 8 is 8. And LCM of 8 and 16 is 16. So that is the maximum value of the fraction. So that comes out to be 16. 8 plus 4 plus 2 plus 1. And that is the answer. Answer is 15 by 16. You cannot make it more than that answer. Not possible. If you take 3, the number will be obviously greater. Options are given 81 also. So if I try to take it 81, so it will be 1 by 3, 1 by 9, 1 by 27 and 1 by 81. And that obviously will be less than 15 by 16. You can check it. 27 plus 9 plus 3 plus 1, that will be 36. 36 plus 4 is 40 by 81, which is not even half. That is even less than half. So that cannot be maximum. The maximum value is 15 by 16. Option B. Come to the next one. So the next one, next question says a chocolate dealer has to send chocolates of 3 brands to a shopkeeper. All the brands are packed in the boxes of the same size. The number of boxes to be sent is 96 of brand A, 240 of brand B, and 336 of brand C. These boxes are to be packed in the cartons of same size. So the boxes has to be same size, containing equal number of boxes. Containing equal number of boxes. Each carton should contain boxes of the same brand of chocolate. So each carton can have only same brand. What could be the minimum number of carton that the dealer has to be sent? So if you want to minimize, we try to put it as maximum as possible number of chocolates in a box, and that number has to be equal. So what is that number in which 96 can be divided? What is that number in which 240 can be divided? What is that number in which 336 can be divided? Which is nothing, which is the highest common factor of these three numbers. So basically in this question, first we need to find the HCF of these three numbers, because only then I can divide 96 in that number, I can divide 240, I can divide 336. So if I factorize it, that is 24 into 4, that is 24 into 10, and that is 24 into 14. Can I take something more common? Yes, I can take it something more common. So can I say it as 24 into 2 into 2? That is 24 into 2 into 5, and that is 24 into 2 into 7. So basically the highest common factor is coming out to be 48, which is available in all the numbers. I cannot take more common from 2, 5 and 7. So what is the HCF? HCF is 48. It means I can put 48 boxes or 48 chocolates in a particular box, right? So how many boxes are required of brand A? If I put 48 chocolates in a box, how many boxes are required? 2 boxes. How many boxes are required? 5 boxes. How many boxes are required? It's 7 times. So 14 boxes or 14 cartons are required minimum. Right? So first we find the HCF, and then we find out number of cartons. Number of cartons can be 2 of brand A, 5 of brand B, and 7 of brand C. So total 14 cartons required. Okay. From the next one. AN is 1111 written n number of times. We need to find out that A741 means A is written 741 is a prime or not a prime. Now first you should know a rule that any number written composite number of times cannot be prime. Any number is written composite number of times can't be prime. Means any number written 10 times cannot be prime. Any number written 12 times cannot be prime. Right? And even if it is written prime number of times, then also we can definitely not say it is prime or not. Look at here. 111 is written 741 times. So it is a prime or not? What is 7 plus 4 plus 1? 7 plus 4 plus 1 or 741, it's 12. So if you write 111 740 times, 741 times, the sum will be 741, and 741 is a multiple of 3. 741 is 12. For 3 you know the rule, sum of the digit. So it becomes 12, and 12 is divisible by 3. So 741 is not a prime number. So 111, if we write 741 times, it will be divisible by 3. If it is divisible by 3, it cannot be prime. So it's not a prime. Yes, it's not a prime. It's a correct statement. So look at here. 5 plus 3 plus 4. Again, it makes 12. So 111 534 times. Again, it will be divisible by 3. 534. 534 is divisible by 3. So sum will be 534. 534 is divisible by 3. So this number cannot be prime. That is also true. 123 is not a prime. That is also true. 1 plus 2 plus 3. 77. Now 111 is written 77 times. Now what did I say? 111 is written composite number of times. 77 is a composite number of times. So this number B cannot be prime. You need to remember this rule. I'm not going into detail of that rule right now because we are just discussing the question, not the rule. So for the timing, you can just remember that any number written composite number of times cannot be prime. So that is also true. So what is the option? It's not a prime, it's not a prime, it's not a prime, it's not a prime. Yes, all of them are correct statement. None of them, it's a prime. All of them are correct. So what is the answer? Answer is the fourth one.